fractions of a quantity. A sort of situation you might encounter this in is somebody's buying something with some package. Let's do the maths. If it's 1/4, then we're sharing the deposit into 4 bits. We're sharing the price into 4 bits. The deposit is one of those 4 bits. That's just a division sum. So we're going to take 5, 8, 5, and we're going to divide it by 4. £146.25. Okay, so that's it. So to find a 1/4 or something, you just divide by 4. What if the deposit had been 3/4 of the advertised price? Well, at that rate, you'd still want to find what 1/4 was, but then you just need to know what 3 of those 1/4s is. So we'll have to take our 1/4 and we'll times it by 3. Then our deposit would be £438.75. That would be rather a large deposit for something that cost £585. But the point is to find 3/4 of 585. You do 585 divided by 4, because that gives you 1/4, and then times it by 3, because that gives you 3/4. Divide by the bottom, and you times by the top of the fraction. Okay, and some people like to just remember it like that: divide by the bottom, times by the top. Or you can think it through and say, well, if I want 3/4 of something, I need to find 1/4. That's sharing it into 4 bits. I'm going to divide by 4, and then I wanted 3/4, so I'm going to have to times that by 3. See, finally comparing fractions. Well, we can have a number of different situations. Which is bigger? 1/3 or 1/4? Well, actually, you don't need to do any calculations for that, because if I take my cake and I share it into 3, and I take my cake and I share it into 4, you can see which of those is bigger. 1/3 is bigger than 1/4. Okay, and you can see that. And it's because you're sharing your whole into fewer pieces if it's 1/3 than if it's 1/4. So 1/6 is bigger than 1/25. I am not going to attempt to share a cake into 25 pieces, but you can see that 1/6 of a cake is going to be a lot bigger than 1/25 of a cake. How about, though, if I say which is bigger, or arrange in order or whatever, and I give you 3/8 or 5/9 or 0.543. Okay, now it's slightly more complicated. We could get these into equivalent fractions. We could say, well, 3/8, how many 72ths is that? 5/9, how many 72ths is that? And then we could compare them. But that still leaves out the decimal. So probably in this case, we're best doing these as divisions to get ourselves decimals, and then we can compare them. So let's have a look. 3/8, that is 3 shared between 8. We know we're going to need to carry it over, so we may as well put that in. 8 into 3, that's not helping me. 8 into 30, well, 8 into 24 goes 3 times, and I've got 6 left over. 8 into 60, well, 8 into 56 goes 7 times, and I've got 4 left over. 8 into 40 goes 5 times. So 3/8, 0.375. We've done that one before. And then we can say 5/9. So that's 5 shared between 9 people. We know we're going to need that. So that's going to be 0. We've got 5 there. 45 would be 5. We've got 5 left over. 45 would be 5, and we've got 5 left over. I think you can see this is going to go on forever. Right, there we go. But we were trying to compare 3 numbers. We've got 3/8, 0.375. We've got 0.555. 5, 5, 5, 5. It goes on forever. And we've got 0.543. Okay. So, in order to compare these, we're needing to look at putting them in order. So 0.3, that's going to be less than 0.5, but both of these are 0.5. So we can say that this is the smallest. But if we're just looking at the tenths column, we can't say which of these is biggest. So let's go down to the next column, the hundreds column. Well, that's got 5 hundredths, that's only got 4 hundredths. So this one is smaller. It's not the smallest, but it's smaller, and this one is the biggest. So we can say, and that one, that was 5/9. That one was 3/8, and that was just our decimal. So smallest to largest. We've got 3/8 was the smallest. The next one is 0.543, and the biggest one was 5/9. So we've got those in order. Next, adding fractions. Oops. Adding and taking away. Okay, so you get questions like Gerald has used 3/8 of his, what sort of questions are these? Never mind. 3/8 plus 2/9. So 3/8 plus 2/9, we can't add those together until we've got them into the same size of pieces. I mean, remember, this means 3 slices of cake cut into 8. That means 2 slices of cake cut into 9ths. That's not going to be very easy to do. But if we turn both of these into the same number on the bottom, so if we times this one top and bottom by whatever is here, we haven't changed what that number is. It's going to be an equivalent fraction when we're finished with it. And if we times the top and bottom of this by whatever's on the bottom here, what we end up with is 3 9s are 27, 8 9s are 72, 2 8s are 16, 8 9s are 72. We end up with the same number on the bottom, and then we can do it really easily. Now, when my daughter was taught this at school, she was taught it as the smile and kiss method. So you can think of it as like that if you want. So you've got the timesing those together, that produces your kiss. Timesing those together, that produces your smile. If that makes you happy, do it. Think of it like that. At any rate, we've got 27 plus 16, 37 plus 6, 43 over 72. Okay, and if we were taking them away, minus 2/9, you're still going to do your smile and kiss method. So 3 times 9 is 27. 8 times 2 is 16. And your smile bit, 8 9s are 72. So 27 take away 16, 17 take away 6, 11. So you just have to get the same number on the bottom, and you do that by multiplying by whatever's on the bottom of the other fraction, because that will give you the same number on the bottom of the two fractions. That's called the common denominator, you might remember that. And then you either add or subtract, depending on what you were trying to do. Let's look at another one. 8 over 13 plus 7 over 6. Okay, it's going to be awkward numbers, but we can do it. So we're going to times top and bottom of this by 6. We're going to times top and bottom of this by 13. And that will give you 48 over 60 plus 18, 78, plus 70 plus 21, 91. Over 78. Let's just stop there. Okay, so what have we looked at? We've looked at what is a fraction. A fraction is looking at parts of wholes, and we can draw pictures of it, but we can also say a fraction is a division, and we can do that division to produce a decimal. We've looked at simplifying and equivalent fractions, and basically what we said is you can times or divide the top and bottom of a fraction by anything you like, so long as it's the same thing top and bottom, and what you will get is an equivalent number. So here we're timesing by 4. Here we're looking at simplifying, so it's the biggest thing you can divide into both the top and the bottom and get a whole number out. You can do it in multiple stages, you don't have to do it all at one go. Mixed numbers, we're looking at that, and we're saying with 3.5, well, 3, each whole number is 2 halves. So that gives us how many halves we got from the whole numbers, plus the extra one. Looking at 2 and 3/8, each whole number is 8/8. So we're looking at how many whole ones we can get. We can get 8 plus another 8 plus the 3/8, that gives us 19/8. We looked at how you went from a top heavy fraction back to a mixed number, and that's just doing division but giving yourself remainders and turning them into the fraction division signs. We looked at fractions of numbers, so if you're trying to find 3/4 of a number, you're just going to divide by the bottom and you're going to times by the top, so divide by 4 times by 3. Comparing fractions, if they're what's known as unitary fractions, if they've got a 1 on the top, then it's very easy. It's whichever is the smallest number on the bottom, because that means you divided your one whole into fewer parts. That's going to be bigger. If you've got not unitary fractions, you're probably best doing the division. Turn it into a decimal, particularly if you're trying to compare it with decimals. Adding fractions or taking them away, first thing you have to do is get the same number on the bottom of both fractions. So that's easy enough. You're timesing the top and bottom of the first fraction by whatever's on the bottom of the second fraction, and vice versa. And that will automatically get you the same number on the bottom of both of them, and then you're just adding the tops together. Or if it's a take away sum, you're taking them away.